Welcome, and in today's video, we're going to be talking about plate tectonics. My name is Eli Brown. I'm a geologist, as you can tell by the outfit. So let's get right into it. The first thing we're going to be talking about is what are plates? Plates are pieces of the Earth's crust that sit on top of the mantle, and they move around. Well, why do they move around? Good question. Thank you for asking. This occurs whenever convection currents inside the mantle, which is just below the Earth's crust, move around. And so the magma inside the mantle, as it gets heated by the Earth's core, it rises, and then as it cools, it goes back down, and then it heats up. And this repeats, and it causes the plate to sit on top of the magma to move around. And so where these two plates meet is called a plate boundary. And there's three kinds of plate boundaries. The first kind that we're going to be talking about is a convergent boundary. This is a boundary where the more dense plate sinks below the less dense plate. This typically occurs when a continental plate and an oceanic plate meet, and this can cause trenches like the Mariana Trench, and it can cause mountain ranges like the Himalayas. And now we're going to be talking about the next one. We're going to be talking about divergent boundaries. This occurs whenever two plates are moving away from each other. This is less common than the other two, and these occur, for example, the mid-Atlantic ridge, where the two plates are moving apart from each other. And in the middle, it creates an oceanic ridge, and it also makes new crust. So all the new rocks come from inside the Earth's crust, or inside the Earth's mantle, and as it goes out, it makes new crust. And this is how we can also age or know the age of the rocks by how far away they are from divergent boundaries. And the last one that we're going to be talking about is transform boundaries. Now, this occurs whenever two plates are moving in opposite directions, and as they go, they slide past each other and slip. And whenever these slip, these cause things like earthquakes. And so, obviously, maybe not obviously, the first thing that comes to my mind, at least, is the San Andreas Fault. This is a fault around California that causes all of the earthquakes in the area, and it affects people's daily lives, so they have to build structures differently. Like, for example, the Golden Gate Bridge is made to withstand earthquakes and constant moving. And so now we're going to be talking about Pangea. And so Pangea it goes along with the original theory of continental drift, and that's sort of where plate tectonics came from. So Alfred Wegener, he theorized about continental drift. He saw that the coast of Africa and Europe meets with the coast of North America and South America, and he thought that maybe they were at some point together, which they were, but he didn't know how to explain that the continents were moving yet. And so not a whole lot of people accepted his idea, until eventually they came up with plate tectonics. And so Alfred Wegener was correct that the continents were at one point together, and that was Pangea, as you can see in the slideshow. I don't know how I'm going to format this yet, but yes, that's all. Thank you for watching. Rock on. Get it? Because it's a geologist. I know, right? Okay, I'm hot in this. Get off.